Now, in terms of these superpowers, it makes sense to me that students need to be able to see it, say it, and symbolize it in multiple ways. And that these superpower understandings, if teachers know what they are, then they could start teaching their students to look at math through the prism of these superpower understandings.
Absolutely.
So that begs my next question, Patrick, which is, what would a typical modeling of math look like with any one of these superpower understandings or combination of superpower understandings?
We had base 10 blocks. I wrote a problem up like, I don't know, 38 plus 45, and I wanted you to model that. So on the place value grid. Now, what's different about my place value, Matt, is we bring the units, we can either write them in or, you have little pieces that you put there. But so bottom line is, I said, what, 38 plus 57, I think, something like that. What you'd have is, okay, I'm going to model. I need 3 10s and 5 10s. I need 8 1s and 7 1s. And they're on the mat. Okay. And I've got them under my place values, 10s and 1s. Okay. Well, I can now take those 10 1s and I can equally exchange that for 1 10 and I can do that operation. And now here's the crazy part. I can go through and do that operation, finish the problem. But the crazy part is, you know what? I'm going to remove those. I'm going to take away those. My units are no longer 10s and 1s. So as long as they're consecutive units, I'm essentially doing the same operations. I'm going to bundle together 10 of whatever it was I had on the right list, and now that's going to become 1 1. So now my students don't just see 38 plus 57, they see 380 plus 570, and they realize, wait a minute, I don't have to learn something different for each of those because it's the same action. I just have to pay attention to the unit that is represented by each of those numerals.
So, what would be some of the questions a teacher could ask students to get them to see those different units, the same mathematical process or procedure?
So one of the things that we commonly ask students in the addition example that I gave you was, okay, so you took these 10 what? What are those? And they're 10, for example, in the first example I gave you was 38 plus 57, I think. But what do you have there? What are they? Well, I have 10 of what? 10 ones, and I moved them over here. You exchange that. You actually took them off the board and gave me a rod, what's that rod? That's one. And I think the biggest thing for teachers that I try to emphasize is talk about the unit, make the unit as explicit as you can. So even if your textbook writes addition problems vertically, is, let's say, again, it's written vertically, the standard notation, 57 plus 38, whatever, draw that line down the middle, those lines, break those up and write the unit that goes above those. But make it very explicit that you're still dealing with it. You don't make it accessible and obvious to students, make it visible, I guess is what I'm trying to say. That's going to be really critical. And then you ask students down the road, once they get used to this, you can ask them, the key is to put problems in tandem. So in worksheets and things, you start to ask different questions. How is 38 plus 57 similar to 380 plus 570? How is it different? But you group problems differently because you're wanting students, again, to look at, we want them to see structure. And by seeing structure, we're looking at helping them make connections. And so those analogous problems, the emphasis on equal exchanges, the emphasis on the tethering of quantities and size of units is all about making that structure be what's most apparent and less emphasis on the procedure and doing a bunch of problems that way.